So for number 2 in the closure packet, it gives us a point, 0, 4, and asks if it's a solution to this system of inequalities. So anytime we want to know if a point is a solution to something, we just plug it in and see if it gives us a true statement. And for this point to be a solution to the system means like more than one inequality, it's going to have to make both of these true, so we're going to have to check it in both of them. So this top one I'm going to start with. The 0 is my x value, the 4 is my y value. X is always your first, y is always your second in a point. So for y, I'm going to plug in 4. So I'm rewriting this first one, plugging in my y value of 4, keeping the inequality sign, and then plugging in my x value of 0 for x. And then I'm just going to simplify the right side to see if that's a true statement or not. So negative 3 times 0 would be 0. Adding 4 gives me 4. So I get this statement, 4 is less than or equal to 4. That is true because 4 is equal to 4. And when it's less than or equal to, it's true either way, whether it's less than or equal. Okay, and then for this bottom inequality, I'm going to plug in my x and y values to that one. So again, for y, I'm going to plug in the y value from the point, which was 4. I'm going to plug in the x value of 0 for both x's. So when I do that, I just have to decide if this is true. So I'm going to simplify the right side. 0 squared is 0. 3 times 0 is 0. 0 plus 0 minus 2 is negative 2. So I get the statement 4 is greater than negative 2, which is true. A positive is always greater than a negative. So since that point made both inequalities true, I would say yes, it is a solution to the system. If it had been false for either one of them, I would have said no.